So today we're going to jump into some really, really fundamental stuff with programming. And those fundamental things are variables, types, and string formatting. Those will stack up to some actual work that we're going to be doing. While I'm talking, always a good idea to kind of get yourself logged into the computer. Might be good to open a web browser with Canvas in it. What's that? Oh, you're good. You're fine. You're fine. Hope you brought enough to share with the class. Um, so, and also PyCharm, to have those two things just kind of open, because I'll reference those periodically throughout most of our classes. But first, I want to talk a little bit about Python. Worst dry erase board ever. I want to talk about Python as a language, because I want you to know a little bit about Python, but I also want you to know how incredibly popular and valuable Python is in the whole scheme of the programming world. So where did Python come from? This gentleman, Guido van Rossum, who was a researcher in Europe in the late 1980s, actually built Python. In the 80s, I can speak to that because I was there. In the 80s, a lot of computing was do-it-yourself, because there just wasn't like an Apple store that you could go to and just pick up a nice shiny new laptop that was all put together and functional. If you wanted a home computer, you typically built it out of electronic components. I don't know if you've seen the picture of the first Apple computer, the Apple I, but it literally was built inside of a wooden box, because you couldn't go buy a computer case on Amazon because none of those things existed yet. They literally, Steve Wozniak and Steve Jobs built a wooden box to encase the prototype of this Apple I computer. Very clearly made in their garage, which it was. But so in this do-it-yourself time and age of computing, if you were unhappy with a programming language, there wasn't 17 other programming languages that you could choose from that had other options. You just made a computer language that had the stuff you wanted. So this Van Rossum fellow was trying to do research, and he wasn't a computer scientist or software developer. Those weren't actual jobs at that point. He was just a scientific researcher. But he used computers to analyze his data. What he found was the language that he was using, which was called ABC, had some great things. It did most of what he wanted it to do, but it had a few features that would have helped him do his job a lot better and faster and easier. And so what he did, because he was a super nerdy kind of guy and very motivated, is he wrote his own programming language called Python. So he named it after, not the snake, actually, even though we commonly use the snake, but anybody recognize this movie? Any hard, yeah, and the Holy Grail, right? I just want to have two coconuts to bang together. You would get that if you watched the movie. But this is very dry British humor from the 70s and 80s. Anyway, interesting movie. If you like either you like British humor or you hate it, typically. There's not very many people in the middle. But Monty Python was his inspiration for the Python language name, not the snake. So if anybody challenges you to trivia, now you know some trivia. Over the years, people have developed this creed or this set of rules that support what Python is all about. They call it the Zen of Python, because Python is a very Zen language. It's made to be easy to understand. It's made to be easy to use. It's made to be accessible for both learning, but also really powerful and extensible for advanced projects. It is, in a lot of ways, the ideal computer language. And in my opinion, there is no better computer language to learn first. Python is a great first language because it can do so much. But the idea here is beautiful is better than ugly, meaning your code. Obviously, beautiful is better than ugly, but what it means is the way you write and format your code should be visually attractive and readable. Explicit is better than implicit, so don't assume things. Simple is better than complex. Complex is better than complicated. You kind of see the idea here that the ideal is simple. Keep it simple is a very important value of Python. Flat is better than nested. I'm going to show you what that means in code over the course of this semester. I will be referring back to this. Sparse is better than dense. Readability counts. So you kind of get a sense of what this computer programming language values, or what's important when you're creating Python programs isn't just these really complicated, hard to understand programs. The idea is that we're working hard to create programs that do things in the simplest, most accessible way possible. And that's so you can read it, but also so that you can collaborate with others. And Python is a very collaborative language. So what's so great about Python? And let me just tell you, Python is great. It's easy to learn. It uses a more natural language. What does that mean? If you've seen other programming languages, you will know that reading them, trying to make sense of, you don't know the language and you read some code in another language like C++ or even Java, what you'll see is that it's hard to understand what's going on in a C++ or Java program if you don't know the language. Python, on the other hand, isn't really that way. Python actually is built to have human readable commands and functions and structures. And the nice thing about that is that it makes it easier to learn. It is versatile, meaning it can do a lot of things, but even the things it can't do, it can still do because it's extensible. So Python has a set of program functions and structures and ideas and abilities built in. But if you decide, if you're like Guido van Rossum, you decide, hey, Python is close to what I want to do, but doesn't really do what I want to do. Like I'd like to power my dog entertainment robot to make sure that it feeds the dog twice a day, but also plays catch with my dog. You can do that with Python because literally anything that's not in Python, you can create a module that adds that to Python. So you can do anything you want with it. Now, what does anything you want mean? Literally anything. Because you can even use other programming languages to create modules that interface with Python. It's that flexible. You're going to need a computer. You're getting one, right? Sir in the back? You're getting a computer though, right? Yeah. Okay, cool. I just want to make sure because you're going to want one for sure. The great user community is great because it's so huge, because so many people use Python for so many different things that people have built these add-on modules and share them with each other. So there's all kinds of things already out there in the world that you can use and pick up once you know the basics of Python, which you will at the end of this class. So how popular is Python? Yes, sir.
Is taking someone else's code plagiarism?
Plagiarism is when you take credit for somebody else's ideas. So if you use my code and you say this code was done by Bill Mosley, or if I put that code out there and I say this is free to use, then no, it's not plagiarism. If you take somebody else's code and you say this was my idea that I created by myself, that's plagiarism. Okay. So code sharing is very common in most programming languages, even more so with Python. So most of the time, taking other people's code is totally okay. And I'm talking in like out in the world. In the context of this class, as I've said before, it's important to write your own code because this is a learning experience. I don't need, in case there's any question about this, I don't need you all to develop little programs for me times 100 or whatever, how many programs I get turned in of the same thing. I don't need you to develop things. So the idea is not really that you're giving me code. The idea is that you're learning something through the experience of writing code. So how popular is Python? This TIOBE index